Dear students, welcome to HomeLearns class. In this class, I will teach you about the functions that is in class 11 Mathematics chapter 2. In the previous classes, you study about the relations and the sets and the difference between relations and functions. There was a introductory chapter also. Now, as we all know that relation and functions are the most important concept in mathematics. What is the function? We can define function that function is a rule that produces new elements out of some given element. So there are many terms we can use for the function, that is the mapping. These are used to denote a function. So when a relation becomes a function, let there be a two set, a relation f from a set A and another set B. Both set must be non-empty. Then function, we can say the relation is said to be a function for both of these sets A to B, set A to B, if every element of A has one and one only image in B. Not duplicacy, as I have already told you in the previous chapter, with the help of the example that 1 2 1 3 2 5 3 6. Is it a function? No, it is not a function because the first value is repeated here. Or simply graphically we can represent what is the meaning of the values, like 1 2 and 3, and here 2 3 5 6. If 1 2 is the image of 1, 3 is as well as also the image of 1. 2 5 3 6. But this relation is not a function. This relation is not a function. Why? There are two images for this single element. So this is not a function, it is a relation. I hope you understood it well. The function is a relation from non-empty set A to B if there are no two distinct ordered pairs have the same element. First element must not be same. Means, or in simple word, we can say that not more than two images of an element. So if a function from A to B, there are two sets A, B, and A, B belongs to F, then we can say that F A is equal to B. So here B is known as an image of A, element A. B is a image of element A. A is called the pre-image of B. Then the function would be if 1 2 2 3 4 5 7 9. This is the function because each element has one and only one image. 5, 7. One and only one image. One has 2, 2, 3, 4, 5, 7, 9, etc. This element is x, this element is y. X. So x, or in simple, more simple word to if you see a relation like this, then you can answer quickly by seeing only the elements. If x is repeated, then that would not be a function. No duplicacy in the x values. I hope you understand this function very well. Now let's understood more with the help of let's understand more with the help of the examples. Let n be a natural number. N is a set of natural numbers. R is a relation be defined on such that R is such that x y is y is such that y is equal to 2x, where x y belongs to n. This is a relation. It is in set builder form. What this relation mean? There are two elements x y. Y is equal to 2x. It means y is an even number always. Y is an even number because it is multiplied by 2. What is the domain, codomain, and range of R? Is this relation a function? What is the domain? Domain is the first value, means 1. Domain is the natural number. Domain of this is set of natural numbers. Set of natural numbers. Codomain, the image value, that is the y. It is the codomain is also natural number. Set of natural number. Codomain is also the set of natural number, and range. Range is the image value. Range is set of even natural numbers. Set of even natural numbers. Is the range. Is this a function? For function to be a function, if I put x is 1, then y would be 2. X is 2, then y will be 4. X is 3, then y will be 6. X is 4, then y will be 8. And so on. This relation is a function because there is one and only one image of first value. 1, 2, 3, 4, or you can show it graphically. 1, 2, 3, 4, 2, 4, 6, 8. No duplicates is there. It is a function. I hope you understood the function very well. Now, with the help of some more examples, you will clear more doubts also. Let R be a function. R is a relation 2, 1, 3, 1, 4, 2. This. You have to state if this relation is a function or not. Can you tell me? Yes, this relation is a function because all the elements in X value have one image only. 2, 3, 4, 1, 1, 2. That means 2 has only one image, 3 has only one image, 4 has only one image. Then this is a function. Let one more example. There is a relation 2, 2, 2, 4, 3, 3, 4, 4. R is a relation. Is this relation a function? Can anybody tell? This is the 2. Let's show it graphically. 2, 2, 3, and 4. 2, 4, 3, 4. This 2 has image 2. And this 2 has also image 4. It means only one element has two images. And this contradicts the definition of function that there must not be more than one image. So it is not a function. This is not a function. And you can do remaining examples in your book. Okay, I hope you have fully understood the meaning of the function or the functions and relations and sets. Let's move further. A function has either a relation or one of its subsets of as its range is called real value function. If its domain is real and subset of real, it is called a real function. Domain is real, subset is real, then it is called a real function. So define a real valued function. Real valued function may be defined, let n be a set of natural numbers. Then a function can be defined, real valued function can be defined, n is such that n by fx is equal to 2x plus 1. 2x plus 1. Then what is the real value of this? That if x is given 1, then f1 would be 3. If x is 2, then f2 would be 5, and so on. So this is a real valued function, and by fx is 2x plus 1. Now let's define some more functions and their graphs. One function is identity function. Identity function. As the name suggests, what is the identity function? If a function has both the elements are equal, means x and y are equal, then that is known as a identity function. Let R be the set of real numbers. R is set of real numbers. So real valued function can be defined. Real valued, as I have explained earlier, real valued f is such that R is R by y is equal to fx is equal to x, where x belongs to R. Y is equal to x, fx is equal to x, y is equal to fx, x. It means for each value of x, y is same. We can denote it with the help of the graph. This is a straight line graph, because for each and every x there would be y. This is a straight line graph because for each of the x, domain and range would be the real number. So for each of x, y is similar. If x is 1, then y would be 1. If x is 2, then y would be 2. X 3, y is 3. I hope you understand it well. Next function is constant function. Constant function. Let define f such that R is R by y is equal to fx is equal to c. It means this value is constant and where x belongs to R. C is a constant, and for each x belongs to R, domain and range. Domain, what would be the domain? Domain would be R and range would be constant. Domain is the real number, set of real numbers, and range would be C, that is the constant. And graphically we can show it as a line parallel to this because this is for the constant, or this. The line parallel to this, it is the constant line. Value would be the constant. If fx is 3, then it would be 3. Fx is 5, then it would be 5 only. So graph line parallel to x-axis. This is the x-axis, this is the y-axis. Now one more function is the polynomial function. As you have studied polynomial in your previous classes, class 9, in class 8 also, class 10, polynomial function. So a function f where R is known as a polynomial if it would be polynomial if for x belongs to R in R, y is such that fx is equal to a0 plus a1x plus a2x to until an xn. where n is a non-negative integer. Non-negative integer, non-negative integer, and a0, a1, this belongs to R, real number. These are the real numbers, and n is a non-negative integers. So that is the polynomial. That is the polynomial function. So some examples of the polynomials are because non-negative integer that cannot be the fraction. This is the polynomial. These are the examples of the polynomial. These are the polynomial, but this can't be the polynomial. This is not a polynomial because its value is non-negative. It is in fractional, not integer. Non-negative integer values. It has no non-negative integer values. Like let's consider it like a parabolic graph, graphically represented. We can graphically represent it with the help of R is R by Y is fx is x square. X square. It means for x is 1, y is 1, x is 2, y is 4, x is 3, y is 8, x is minus 1, then it would be 1, minus 2, then it would be 4, minus 3, then it would be 8. So graphically we can represent it as these are the x and y axis. This is the x axis, this is y axis. Two, 4, 6, 8, minus 2, minus 4, minus 6, minus 8. This is the x negative value. These are the x positive values. Y positive values 2, 4, 6, 8. So for each and every x minus 2, minus 4, minus 6, minus 8, the graph for the polynomial can be, or these are for the positive values and this is for the negative value. This is the parabolic form. The domain of this is f is equal to x is such that x belongs to real number and range is, this is the domain, and range of f is equal to x square. X is such that x belongs to a real number. This is the range and x value is r. The polynomial function. Again, the next is the rational function. Rational function. These are the functions of the type in the fraction fx by gx. Fx by gx where gx is not equal to 0. The function of this type where fx by gx, where gx is not equal to 0, is known as a rational functions. Fx and gx are the polynomial functions of x defined in a domain. These are the polynomial function defined in a domain where gx is not equal to 0. What would be the real values for real valued function? If we let's take an example, f is such that r minus 0 belongs to r, and it is defined by fx is equal to 1 by x, where x belongs to r minus 0, r minus 0. So if you have the values minus 2, 1.5 and 1, this is the x value, then what would be the fx? Or we can say that y, it is the y. 1 by x. 1 by x means 1 by minus 2. It is minus 0.5. 1.5. 1 by 1.5. 10 by 15 or 3 by 5, or it may be the 0.67. And 1, if it is minus 1, then it would be the minus 1. So that are the values. So domain here, what is the domain? Domain of such type of real valued function is domain. Domain is all real valued, all real numbers except 0, because r minus 0. And range is also all real numbers except 0. So graphically you can represent this as x, y, like this. This is the y negative number, this is the x negative number, this is the x j. So this is for the fx is 1 by x. Then one more important function, that is the modulus function. Modulus function. The function set of real number, not to real number, is defined by fx is equal to x. For each x belongs to r is called a modulus function. If a function is in this form, then it is known as a modulus function for each non-negative value of x. Fx is equal to x, and for negative values, the value of function is the negative values. It means it is denoted as plus minus x. Means for positive value, it is for positive, and for negative values, it would be the negative. Or simply we can state it as fx is equal to, function is represented as x. If x is greater than 0, then it would be the x, and minus x if x is less than 0. Graphically, it can be represented like this. This is x, this is y, x negative, Why negative? Yes. Then it is for positive value for positive and negative values for negative. The modulus function. It is for positive non-negative integers value of x is equal to x. For negative values of x, the value of x is negative. And next comes out to be the signum function. Signum. The function is such that R real number set of real numbers belongs to real number, that is the domain and range. It is defined by fx is equal to 1 if x is greater than 0, 0 if x is equal to 0, and minus if x is less than 0. So this is known as a signum function. The domain of the signum function is real numbers. Domain of signum function is the domain. Domain is the real numbers. But range, what about the range? Range is a set of -1, 0, 1. This would be the range for this set signum function. And then the greatest integer function. Greatest integer function. Greatest integer function R is a set of R is a real numbers defined by fx is equal to x such that x belongs to R. R assumes the value of greatest integer less than or equal to x. The greatest integer less than or equal to x. Less than or equal to x. Let's consider 1.5. There is an integer 1.5. Then the value of this would be 1. Greatest integer would be 1. 3.99. Greatest integer would be 3. 4.2. Greatest integer would be 4. So this is the greatest integer function states that value of the greatest integer less than or equal to x. 3 has 3 less than or equal to x. If it is x, then 1 is the greatest integer. Then 3 is the greater less than or equal to x. That must be integer. It is 4.2. It means 4.2. It's in fraction, and 4 is the integer. This is the greatest integer. Again 3, 3. Less than or equal to. I hope you understand all the functions very well. If you have any problem in any of the functions, please comment us. Let's, before going to the exercise, or in next class, we will do the exercise. Let's discuss some more functions, that is the algebra of real functions. How real functions can be added, can be subtracted, multiplied, or divided. So in this section, that the algebra of real functions, algebra of real functions, we shall learn how to add real function, subtract a real function from another function, multiply a real function by a scalar. Scalar means any real number, any real number. Multiply two real functions, divide one real function by another. That addition of two real numbers. Real functions. Addition of two real functions. Addition of two real functions. Let f is such that x x implies to R, belongs to R, and G is a set of G is such that x is a set of real numbers. These are the two real numbers where x is a subset of real numbers. We can define f plus g such that x belongs to R by x implies to R by f plus g x is equal to fx plus gx for all x belongs to R. That is the addition of two real numbers. When function first fx plus gx. And similarly, we can show subtraction also. F minus gx is equal to fx minus gx for all x belongs to R. Subtraction of real number from another real numbers. Multiplication of a real function by a scalar. Scalar means any real values. Let there be a. A is a scalar number. A is a scalar number. How to show this function f is such that x is a set of real numbers. Real valued function, be a real valued function. A is a scalar value. Then AFX such that x belongs to R. You can multiply. Multiplication of two real numbers. F and G are the two real numbers. Then their multiplication is fgx is equal to fx gx x R. Quotient of two real numbers. Let f and g be two real numbers. F and g be two real numbers such that x is to R, where x is a subset of R. Quotient of f is denoted by f divided by g. Or we can define f divided by g x is equal to fx gx. A condition for it that gx must never be 0 or is not equal to 0 and x belongs to x. That's all about the relations and functions. I hope you understood the concepts of this chapter very well. In the next section, I will solve for you the exercise 2.3. Okay, let's this operations on the real functions. Let's solve it with the help of the example. Fx is x square, gx is 2x plus 1. These are the two real functions. You have to find out what you have to find out. F plus g. What would be the x plus g? X plus gx is equal to x square plus 2x plus 1. F minus g, x square minus 2x minus 1. Because minus sign is out of the bracket, then all internal values will be minus 1. Fg x x square 2x plus 1, that is the 2x cube plus x square, and the function fg is x square divided by 2x plus 1. That's all about the chapter. Keep watching HomeLearns videos for chapter 1, chapter 2. Thank you.